Let's continue with our development in JavaScript programming. And for the next 3 videos, we'll be covering conditions, loops, and functions. So let's create a new JavaScript file. So new, and let's just save this in the same folder as the HTML document. So conditions, loops, and functions.js. So we know when we reference it here, it will find that file. And let's say we're just going to run the main function there, which is show conditions, loops, and functions. Show CLF. Okay. So show CLF is the function that we're running. And here we go. There's our open workspace now. So let's look at our conditions. And among the conditions, we are going to test things like more than, less than, more than, equal, less than, equal. There's also equal to, and then equal to with the type, and then not equal to and not equal to with type. So these are the very simple basic conditions that we can check. So we can say here console.log, and the result of a comparison is a simple boolean. So if we say is 2 more than 3, then yes, it is more than 3. So we expect that to be true. And so we won't run each of these in turn. Let's just run through each of these and see what they do. So console log 2 less than 2 being less than 3. So that is true. So actually here we expect a false and here we expect a true. And then to check whether they are equal, we can use the double equals like that. And let's test 2 that are equal. So we know we should get a true here. Let's also make this a bit more expressive so that we know what the true and false refers to. So we can say here console.log test 2 more than 3, test 2 less than 3, test 2 equals 3, test 3 equals 3. And looking up here, let's test with type. Let's test whether 3 triple equals 3. So 3 triple equals 3. And then as part of that, let's also test whether 3 equals the string 3. And maybe the one that's a bit of a weaker test. Let's test whether 3 equals 3.0. So whether the integer 3 equals the floating point 3. So does 3 equal 3.0? What else did we want? The not conditions as well. So console.log 2 not equal 3. Is 2 not equal 3. And we know that should be true because 2 is not equal to 3. And we can test whether 2 is not equal to 3. So that's either the values are not equal or the types are not equal. So here the values are not equal. So that will definitely be true. But also, what if the values are the same, but the types might not be the same? So 3 not equal to 3.0. So in this case, we expect that to be So it will not be equal. So this should actually be true. So let's run all these. And we'll just be looking in the console for now. So let's expand that. Right, so 2 is not more than 3. So that's false, as we expect. 2 is less than 3, so that is a true. 2 equals 3, that's false. 3 equals 3, that's true. 3 equals 3, and the types are equal. So we didn't explicitly say 3 was an integer, but the compiler will infer that these are both integers, so that's a true. Here, actually, it does recognize this as an integer. So that's a little bit unexpected. So just be aware that using a dot zero, a decimal zero, doesn't imply that this is a fault. This doesn't imply this is a float. So this is still seen as an integer. So it does say the types are equal as well. Here, the string 3 is not the same type of thing as the number 3, so that's a false. And then it is true that 2 is not equal to 3, so that's a true. And then it is true that 2 is not equal to 3. What was the difference here? We should say 3.0, right? So this should be 3.0, although in this case is not. That would be true anyway. It's true for 2 different reasons. And then in this one, we didn't include the 0.0. So just rerunning that. It's true that 2 is not equal to 3, but it's not because of this part, right? This is an integer. The compiler sees this as an integer. So this is not equal to 3 more because the values are not the same. And then 2 not being equal, 3 not being equal to 3. Remember, the compiler will see this as an integer. So it will compare these two. It will see, it will think the types are the same and also the values appear to be the same. So it's not true that 3 is not equal to 3. So that's a false. So those are some aspects of conditions. So those are, if you like, the primitive types of checks. But next we can talk also about combining these. So we can look at console.log, and now we can combine 2 checks. So we could ask, is 3 equal to 3 and 4 equal to 4? And let's just comment out this stuff, and let's focus down here. So that's how you use an and. That's how you include and statements, a double ampersand, right? And so if we run this, we do expect that both those are true. So it's true and true. And so when we run that, we get a true. If one of those is false, right? So if 4 equals 5, let's say, we know this is not true. And so overall, it's not true that this is true and this is true. So if we run this, then we get a false, right? It's false overall for both these statements. It's false because one of those statements is false. Of course, if both statements are false, then it's overall false, right? So the final result of that is also false. And if we wanted, on the other hand, to check whether it was true that one of, not exactly that one of them, but is it true that, that at least one of them is true? So this is the or check, right? So for and, we use the double ampersand, and for or, we use the double pipe. So we want to know, is it true that at least one of these statements is true, right? So that's how you read or statements. And we can have as many ors as we like. So we can have here is it true that 3 equals 3 or 4 equals 4 or 5 equals 5? And so all of that is true, but we only need for one of those to be true. So in this case, let's just start from an and place first. So here it's true that all of those are true. So that is true, and that is true, and that is true. But then we could check whether it's true that one of those is false. So let's say 5 equals 4. We know this is false. So we've got our check here is whether this is true and this is true and this is true, but it's not true here. So that makes the whole thing false, right? So we get a false here. But if we change this to an or, so our check now, and let's be explicit here, when using conditionals, it's better to use more brackets so that you are sure that you are checking. So here we are first checking this condition. Is it true that this and this is true? And yes, this is true. And here this is false. So now we have a true or false. In the case of a true or false, the true always wins, because we are saying that one of those at least is true. So we see now that this is true, even though we have a false here. Because that false occurs in an or branch, then the fact that there does exist a true branch, that means we overall get a true. So if we change all these to ors, that will definitely work, because this is true, or this is true, or this is true. Let's remove these outer brackets here. So that's a true. If all these were false, so if 4 equals 3 and 3 equals 5, let's say, we can see none of these statements are true. So here we are effectively looking at false or false or false. So if they are all false, then there's no way to find a true branch. So we get overall a false here, right? So we can use and or, and we also saw the not condition here. So we could, if we put in a not 4 equals 3, then that makes this part true, right? It is true that 4 is not equal to 3, right? Or another way to say this is 4 not equal to 3. So that's one way to say it. But you can also introduce a not into the whole condition like this. So 4 equals 3 not, right? So that's, so we know this is true. It's not true that, it's not true that 4 equals 3. So overall, this is true. And now we have a true branch, and these are false. But we do have the one true branch. So overall, this makes this a true, right? Because of that. So with and or, and will require everything to be true before it will put out a true, otherwise it's a false. In the case of or, it requires at least one thing to be true before it will put out a true, otherwise it's false. So in the case of or, it's more often the case that it's false, because you need everything to be false for the or connector to be false. And in the case of and, it's a more, if you like, rigorous test. You require everything to be true. So when we write code that directs us into different code blocks, and we want to check that the state is a particular way, then we need to use those kinds of connectors. We need to know how many of the conditions are true, or which of the conditions are true, which of the conditions are false, and then we can direct our code down the right pathway.